In example 2, we're going to find the end behavior for the exponential parent function. And the exponential parent function is, we'll call this one just g of x for grins. We'll go 2 to the x power here. So 2 to the 0 is 1, 2 to the first is 2, and we can start to build our function. And this side never goes below 0. It's really important that you know that. So this just continues up and has kind of a curved shape to it. Alright, and let's see here. So we're going to do end behavior. So we'll do the left side. That says x approaches negative infinity. What does y do, or what does y approach? And then the right hand side, as x approaches infinity, what does y approach? Let's do the left side. So as we go to the left, we can see that these values here just get closer and closer to 0. Remember, it's the y value we're wondering. And we should put an arrowhead there. And to the right, though, as we approach to the right, you can imagine for very, very large values of x, the output here, and I should probably be using the same terminology, g of x. So if you'd prefer that, I think I probably made a mistake in that first video. Use that. Y is okay too, but if g of x is here, we might as well use it. This time, the y values will just approach infinity. They just keep growing and growing and growing. If x is very large, then g of x is going to be very, very, very large as well. You can verify this with a calculator if you'd like. I'll give you a couple ways to look at it. We've kind of looked at the graph, but let's type in 2 to the x power. And what we're going to do is we're going to go to the table, but before we do that, we're going to set up our table. So we have to hit second and then hit window, and that's going to go to your table set. Yours might look a little different than this, but it should be pretty close. Table start, it doesn't matter too much for this, but I like to go 0. When we're looking at end behavior, we're concerned when x is very, very big. So I'm going to put the delta table, which is the change in between x values at 10,000. And you're going to see how that looks. Ooh, this one has an error. That's funny. We'll go back and take a look at that before. But you can see here as x gets very small, we've got 0. So actually, we can back off on that delta table at 10,000 here and make that maybe, oh, I don't know, let's just make it 10. We'll see here. Most times 10,000 will work for a lot of functions, but this is causing us a little bit of grief here. Oop, and then I got to go back to table set and start at 0. Let's try that. Okay, so we've got 1.2 times 10 to the 18th power, which is very large. So you can see here as x continues to increase, this value here just gets bigger and bigger. This is 10 to the 36th power times 1.3. So it's like 13 with a ton of zeros followed by it. And that's going to be a very large number. It'll go to infinity. And here we can see that the left side is multiplied by 10 to the negative 28th power. So it's a point and then a bunch of zeros and then an 8. And so that's getting very, very close to 0 as well.